Hi, how's it going, our chemistry students? Today we are going to learn about measuring pH. Maybe we can do a quick review on what pH is again. So if I go back, the best way to think about pH is this table right here. And if you guys remember, right, the pH is based off of the hydrogen ion concentration. We use that formula opposite of the log of the H plus ion concentration. So that's, and the scale goes from all the way down here to 14. That's because down here you got the 1 molar sodium hydroxide. The other thing to consider is that when you take this and you multiply it times the hydroxide ion concentration, you always get 1 times 10 to the negative 14. So if this one's 1 times 10 to the negative 6, the hydroxide ion concentration is 1 times 10 to the negative 8. If we know the pH scale, you also know the pOH scale just by subtracting 14 from it. And hopefully you guys know that from 0 to 7 here, it's going to be acidic. From 7 to 14, it's going to be a basic solution there. Let's see here. We did these last time. So let's get into measuring pH and how we measure it. An indicator is a valuable tool for measuring pH. So let's say, what is an indicator? I'll give you an example, then I'll go back. So phenolphthalein is an indicator, it's a pH indicator. It's colorless if the pH is 2, 4, 5, 7, but then all of a sudden, and when we're getting into that 9, 10 range, it recognizes the presence of a base and starts to turn pink. So phenolphthalein turns pink in the presence of a base, and it'll turn pink at about a pH of 9. And we have a wide range of indicators that do this for us. It only takes a couple drops of the indicator, so we just put like 1 to 2 drops in each one of these beakers. This one is pH of 9, starting to turn pink. Let me go back. So yeah, like it says there, an indicator is just a valuable tool for measuring pH because the acid form and base forms have different colors. For phenolphthalein, the base form is basically colorless, or for the acid form it's colorless. For the base form, it's going to be pink. So it's actually an application of Le Chatelier's principle. If we add more acid, it shifts it this way, and the indicator has a different color to it. If you take away this by adding a base, it shifts it more towards this form, and this indicator's got those 2 different colors. Well, like that one lab we did, we had the yellow and the orange, that potassium chromate, it switched from different colors. Indicators work the same way. If you add an acid, it'll shift it this way. If you take away it, it's going to shift it this way. And the acid form has a different color than the base form. It's basically how it works. So here's kind of a wide range of some acid-base indicators. Phenolphthalein, you can see, is down here. It's colorless up to about pH of 9, then it starts to turn pink. We have a wide range of these, and it's covering basically the whole spectrum of the pH scale. So thymal blue will be red. That's what this is saying. It's not colorless, it's red on this side of it. All the way up to about a pH of 2. Then it starts to get orangey yellow. And thymal blue is kind of a cool indicator because at this point it goes from yellow to orange, or to green, and the green is at about 8.5. But then it turns to blue again right here. So the thymal blue's got a wide range of colors. So it's actually a really good indicator if we're looking at some different solutions. Some indicators, like phenolphthalein, is really only good for finding a pH of 9. Here's another good one here. It'd be kind of that orange, yellow, then all of a sudden turns to red, then to be more pink, and then more purple. So that's covering a wide range of the spectrum. So yes, these indicators really help us detect pH. We do have universal indicators that actually covers the whole spectrum. There's going to be a video posted on Schoology of how we can actually take red cabbage. We can boil that organic dye out of the red cabbage, which is what turns it kind of the red color, and we can use that as a universal indicator. So you take a little bit of the cabbage juice, essentially, which has the dye in it, and it actually will turn these really cool colors, and it gives us a really nice pH range here. And actually, yeah, this looks to be about like they used a cabbage organic dye, because actually if you take the cabbage leaves, it is kind of a red at pH of 1, and the cabbage will turn blue with a pH of 12, and it actually, you would see all these different colors on the pH scale. So that's one way we can use, like I said, these indicators to measure pH. As technology has improved, we have other ways of measuring it. The pH meter is an excellent tool for measuring pH. It basically gives us down to the tens, hundreds place. Some are even more accurate than that. It's basically just got this little probe here at the end of it. I've used these things in college. We don't have them here at Crosby. They're pretty pricey. But the pH probe, you have to calibrate it in distilled water. So then this beaker's got your distilled water in it. You would hit calibrate. It's like zeroing out the scale. So you hit calibrate, you would know that's distilled water of 7. Then you could test some different solutions, but then you have to basically dip it again in some more distilled water to get recalibrated. They're kind of a touchy tool, but they do work very well. Let's see here, and that's basically it on how we measure pH. There's also just a simple acid base, the litmus paper that you guys seen earlier in the year. You got the litmus red, the litmus blue. It's just some other ways of just checking whether it's an acid or a base. But for measuring pH, best way is looking at pH meters. You're looking at these indicators. So yeah, that'll be that for today.